All right, we're in Algebra 2. Mr. Sandell just gave a huge long intro to Example 1 and Example 2. Today's date is April 25th, 2019. It's a beautiful Thursday. All right, so we're talking about caffeine. I'm assuming that I'm drinking a normal coffee. As we discussed, normal coffee has about 100 milligrams of caffeine. There's our function that models it. We talked about that already. So I just want to plug in a number. How many milligrams of caffeine, again, this is measured in milligrams, mg, how many milligrams of caffeine will I have in my body, or you, if you drink 100 milligrams of caffeine after 4 hours? Okay, 4 is being plugged in somewhere. Where? Quiet, raise your hand. James. The T. Everyone write it down. We're plugging it in for T, so we're saying that C of 4 is equal to 100 times 1/2 to the power of 4 divided by 6, and you punch this in on your calculator and you're done. I will do that for you. The calculator that I'm going to be using is the Desmos Scientific. So 100 times 1/2, 4 to the power of 6. 100 times 1/2 to the power of, in parentheses up here, 4 divided by 6. And I will have roughly 63 milligrams of caffeine, rounding. So this is roughly 66 milligrams of caffeine. Pretty straightforward. On Khan Academy, you're going to be doing the same types of problem where you just plug in. It's as if we went back in time to Unit 7 where we were only dealing with exponentials. Just plug in, see what you're at. This is where we start using logarithms now. I will not be able to sleep, and this is kind of made up because I don't know exactly how many milligrams of caffeine in my body will make me not sleep, but I basically never ever take caffeine. I never drink coffee unless I really need to, so I have no tolerance to it. Eva has like an amazing tolerance to it, and she can go to sleep right after drinking coffee. I know some of you are also like Eva. If I drink like a normal cup of coffee, I'll be shaking all day because I'm not used to the caffeine. So I think 20 milligrams is a safe assessment. I probably won't go to bed unless I have less than 20 milligrams. That might be from a lack of sugars, but hopefully you're okay. All right, so I want to find when this function is equal to 20. I will do that substitution for you. When do I get 20? 20 is equal to the rest of this function. 20 is equal to 100 times 1/2 to the power of t divided by 6. When can I go to sleep? How many hours do I have to wait? I'm solving for t. I'm solving for time because I want to know when I can go to sleep. All right, how am I going to solve? So right now 100 is being multiplied, so the inverse operation of multiply.
Can't you just plug that number into that Desmos thing?
Can you punch this into Desmos? No, you have to move things over and then punch it in. So divide both sides by 100, so divide by 100, divide by 100. I'm now left with 20 over 100, which reduces to 2 over 10, which reduces to 1 over 5. So I now have 1/5, or 0.2 if you want to do a decimal, is equal to 1/2 to the power of t divided by 6. This is where you're thinking, oh no, the variable is trapped in the power. Is there a tool, is there some tool that we've learned that will get that variable out of the power? Yeah, Fiona. Yeah, logarithms. So what am I going to do to both sides? Log base what? Close. 1 over 2. Log base 1 over 2 of both sides. So log base 1 over 2 of 1/5. And that's going to equal to log base 1/2 of 1/2 to the power of, and I'll do double parentheses, to the power of t divided by 6. Okay. Thank you, Fiona. And I guess I should be going back to giving XP. So I know that Fiona just did hers. Who was the last? It was James, right? James. All right, thank you. Okay, what happens now? What happens to that right-hand side, Eva?
The log 1/2 the other 1/2, so it just leaves t over 6.
Yep, it turns into just t divided by 6. All of these cancel out. I guess I can do a slash like that. And that's equal to still log base 0.5 or log base 1/2 of 1/5. And then finally, what am I going to do to both sides? Quiet raised hand. Is there a quiet raised hand out there? Yeah, if you want to go for it. I'm going to multiply both sides by 6, so times 6 times 6. And I'm left with my answer. And I'm going to put my, I'll leave my t over here, sure. T is equal to 6 log base 1/2 of 1/5. And now I enter this in my calculator once I get everything on the same side. So I don't like doing log base 1/2, so I have to rewrite this, and I ran out of room here, so I'm going to have to rewrite this. I'm going to come back up here to the top right. So I still have, I guess 1/5 could be to the power 6. I can move this power back up here. You guys are familiar with power rule? Nodded our head, yes. So what I'm going to do is I'm going to rewrite this as log base 10, or just normal log, of 1/5 to the power of 6. So 1/5 to the power of 6, like that, all over log of 1/2. That is equal to t. That's what I really need to enter in my calculator. The reason that I have to rewrite it is because a lot of calculators cannot handle log base 1/2. I know a lot of us have that ability on our calculators, but that's not all of us. I really want you to understand that log base, other things than e and 10, are hard. You have to rewrite with a change of base formula. And this is the part where we actually start, oops, this is the part where we enter it on our calculator. So if I come over here, go to Desmos, that was good, that was the last problem. So I'm going to say log of 1/5, and that 1/5 was to the power, let me get my parentheses set up here, that 1/5 was to the power of 6. That all is going to be divided by log of 1/2. How many hours will it be until Mr. Sindel can go to bed? Yeah, we'll just round to 2 decimal places, 13.93.
Wait, that's just a regular cup of coffee?
That's 1 regular cup of coffee.
Are you sure that's right?
And that is about right, because if I drink anything past 10 or 11 o'clock a.m., I probably won't be able to go to bed. That number is probably not quite, I probably might increase this to 30 for next time, because that seems a little bit long. But yeah, the whole point here is this is how you use logarithms to solve real-world problems. So 13.93. And I'll use units here, so 13.93 hours. All right. So we're on the back now, unless there's any questions.
I don't get this.
You don't get it?
Yep.
So whenever I have an amount that I'm trying to set equal to, that's going to be set equal to the first initial amount. So if I'm looking for a certain amount, then I have to set it equal to. If I'm looking for a time, I just plug in the time. That's the general way that these work. All right.
Makes sense.
So I talked about Chernobyl a bit. We saw the map. The map was over here. This is where Chernobyl is. It's in Ukraine, northern part of Ukraine, on the border of Ukraine and Belarus. So let's talk about that radioactive cesium-137. So the half-life is 30.2. We're modeling it with a very similar function. T is now measured in years, not hours, not days, but years, right, James? So I want to know, and this is a slightly harder question than Khan Academy will ask you, but I think it's more important. How many years will it take until there's only 1/5 of the initial leaked radioactive cesium? And the cool thing about exponentials, well, I guess cool is probably the wrong word since we're talking about this horrible disaster, but notice here that what I had on the left-hand side, I immediately divided by 100. What I was really saying is, when does this thing have a ratio of 1/5? If I scroll back and look at this guy, this green line right here is saying, when do I have 1/5 of my normal amount, 1/5 of my initial amount? It doesn't matter what the initial was, as long as it's 1/5. So this is the line that we're going to be starting on right now. So I get rid of my initial value, and I just set this equal to 1/5, or sorry, 1/20th. So our first line, 1/20th, is equal to all of this stuff without an initial amount. 1/2. T to the power, T over 30.2. 30.2. I'm going to pause here. because I think what I just did was really confusing. So, I want to take two cases. Someone shout out a number between 10 and 100.
5, 6, wait.
I heard 10.
I think we need to go back to kindergarten.
C of t is equal to 10 times 1/2 of t divided by 30.2. Don't write this down again. So, I need this to be 1/20th the amount. What's 1/20th of 10? What's 10 divided by 20? A half. So what this would end up being is, we'd say 1/2 is equal to 10 times 1/2 to the power of t over 30.2. If we started with 10, then the first step would be divide 10 on both sides. Again, you don't need to write this down. I really just want to focus on understanding it. What would be the first step? Both sides. Divide by 10. Chris has it. If I divide by 10, what's 1/2 divided by 10?
Wait, isn't it just half?
So 1/2 divided by 10, right? Whenever I do division, I keep it. So I keep it, change it, flip it. What's 1/2 times 1/10?
So sorry. In about 4 minutes, it's going to be too late for me to take them. How much
Okay.
more time do you need with them?
They can go right now. All right, so we are back with half of the class missing. So this was the keep it, change it, flip it rule. 1/2 times 1/10. 1/2 times 1/10 is? Multiply the bottoms. 1/2 times 1/10.
20. 1 over 20.
Which is what we just put right here.
Oh my god.
So it doesn't matter what my initial amount is. Again, don't write this down. I'm going to delete all this stuff in a sec. Shout out another number between 10 and 100 that's not 10.
30.
Can we do 50? That's a nice number.
30.
So if I do C of t is equal to 50 times 1/2 to the power of t divided by 30.2, then what is 1/20th of 50? It's 50 over 20, reduces to 5 over 2. So that means in order to get 1/20th of the initial amount, which was 50, I should be looking for 5/2 or 2.5. So the whole problem is saying, how can I get 1/20th of the amount? Well, the amount was 50. We don't know what the amount was. If the amount was 50, then to get 1/20th, we take 5/2. If the amount was 10, then the amount that we're looking for to be 1/20th is 1/2. We don't know what the start is, so we're just making up a number. So if I set 5/2, I can even move this. So if I set 5/2 equal to 50 times 1/2, blah, 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 the first step is going to do what to both sides?
No, that doesn't make any sense, dude.
I'm so lost. Why are we doing this?
Like, you went
You
from
choose
like,
this to go on the final. Or is it going on the final?
oh god.
You can. That's 0.
I would divide both sides by 50 in order to solve this.
Do we write that part?
Yeah.
Can
You don't write this, you're just paying attention. I'm going to divide both sides by 50. 5/2 divided by 50.
Like, where do all these numbers come from?
Do you understand where 5/2 divided by 50 came from? Okay, I need to solve this thing. The first thing I'm going to do to both sides is divide by 50.
Why 50 and not
It's
1/2?
20.
Because
1
that's
over
the
20.
number.
Oh, wait, I get it.
50 is the initial amount, 50 is being multiplied. 1/2 is to a power. I have to get rid of the power before I can deal with the 1/2. 1/2 is being locked by the fact that it's to the power. No, still not getting it?
Yeah, it looks like Chinese to me, but okay. I don't get this.
Why do you have to make this so hard? Or why do they have to be so hard?
Okay, well, let's do this. Since this stuff isn't going to be on Khan Academy, you just sit back and relax and let me take notes. Just try to pay the attention as much as possible. This is how you solve a real-world problem. Real-world problems are hard. You have to apply not just basic math, but advanced math. So we're taking a really core idea, just using logarithms and applying it in a really difficult way. That's why it's hard. And it is hard. I acknowledge, yeah.
I'm just letting my pin.
Okay. The main thing here is this is where I'm starting my equation now. It doesn't matter what the initial amount was. This I got absorbed by this 1/20th, and then I solve.
Wait, it just disappeared?
No, it didn't disappear. So we said we don't know what the initial amount is. So let's say the initial amount was 100. I don't know, some initial amount. In order to have 5% of 100, then I need to somehow get to 5. How do I get from 100 to 5? Well, 100 is going to be doing something right here. This number is going to somehow get you to 5. So then I'm starting to solve this. I have to solve 100 times 1/2, blah, blah, blah. So I divide both sides by 100.
So is it like every time we just put a random like 100, or can we just choose any number?
Again, this is not a Khan Academy assignment, so if you're worried about the procedure, don't worry about it. The second half of this is totally just applied. The first half of this you need to know how to do.
So what's on Khan Academy?
On Khan Academy, these two problems are on Khan Academy. Example 1, part A and part B. Those two are on Khan Academy. Plugging in to time, which I think we can all do, and plugging into a constant amount. If it says an amount, plug in to the left. If it says a time, plug into the time. It's that straightforward, and you're going to have to use logarithms for one, not use logarithms for the other.
Alright, just keep going.
All right. So coming back here, I have this equation. How do I solve this equation? I have a power trapped.
Divide.
I can't divide.
Multiply by 2.
Can't multiply by 2 because
Divide by 1/2.
I can't divide by 1/2. That will not get this undone. It's trapped right now in the
Power
exponent.
something, right?
Log of 1/2.
Log base 1/2.
Yeah, right.
So I'm going to say log base 1/2 of 1/20th.
Write this down
You don't need to write this down. I said you guys can just follow along with your minds
for the rest of the lesson.
for the rest of the lesson.
Wait, is this going to be on the final?
This problem here is not on the final. No.
So can we do something that will be in the final?
Can you just what?
Can we do something that will be in the final?
I just did right there.
Oh shoot! So why are we
Just
doing
let him
this?
do
then?
it. Just let him do it.
Because it's a fun problem.
Just go.
This
Just let him
must be fun to you.
Just go.
All right, well, I'll just go really through this nice and fast. Log base 1/2 of 1/2 of, or 1/2 to the power of t divided by 30.2. Okay, this is going to cancel out. Cancel, cancel, cancel. I'll be left with t over 30.2. I have to multiply by 30.2 on both sides. 30.2 times log base 1/2 of 1/20th. Question?
No.
Okay. And then this is the answer. So if I plug this in the, again, I could do change of base formula, but I'm not going to kick the dead horse. I know that everyone is kind of over it already, so I'll just go through this fast. So what was my initial amount? 30.2. 30.2 times log base 1/2. Log base, come on, let me do base 1/2. Base, okay, fine, 0.5. Log base 0.5 of 1/20th. And the answer is you will have only 5% of the radiation in 130 years. So Chernobyl is going to have a long time before it is not very radioactive. It'll still have 5% radioactivity, I guess. So now I'm going to do the same problem, but skipping some
Can I
steps.
set it up?
Go for it.
1/100 equals.
Same thing. Same thing.
1/2.
Yep.
Why?
Because that's the half-life.
Oh.
The only thing that changed was the thing up front.
T over 30.2.
Exactly. So the only thing that's going to change is the 1/100. So I'm going to change this 20 to a 100, and we'll see that in order to only have 1%, I'm going to have to wait over 200 years for only 1% of cesium-137 to be left behind,
I get
which is a long time. That's multiple generations of people. The end. So you guys are going to be working on count them, one homework assignment that has these two types of problems. So
What the heck?
the homework assignment is already up on Khan Academy. You do not need to write a summary. If you do, I'll write the summary for you. So if you have a general equation where I have y is equal to,
Hey, Gia, do plus for me real quick.
What?
Do plus for me real quick.
y is equal to some initial amount, so let's just say 100 times e to the power of 3x. If it's a time, plug into there. If it's an amount, plug into there. That's the thing that I wanted you to take away from the lesson. Also, how cool math is that it can actually solve real-world problems. But it seems there was a bit of backlash on that. But that's okay.
Why do you look at me, Goose?
You
Why
were-
are you always looking at me, Goose?
It wasn't just you.
It was Teflon too.
Are we okay? By the way, if you do an amount, that's the one that's going to need log. I don't know why I spelled need with an N. M. Needs a log. You'll have to do the log of both sides eventually, if you plug in an amount.
Okay.
Go ahead and try the homework. See if it's as hard as the notes.